Okay, so when we're dealing with some special right triangles, if you remember from geometry, and I think we talked about this in Algebra 2, there are two kinds of special right triangles. We have 30, 60, 90 triangles, and then we have 45, 45, 90 triangles. And basically what we're going to do is kind of develop what those triangles look like on what will be the unit circle when we do the unit circle tomorrow. So in the unit circle, we deal with a radius of 1, and if you can remember from Tuesday, that essentially means that the hypotenuse is equal to 1. So what I'd like to do is just kind of show you some basic structures by building these 30, 60, 90 triangles and 45, 45, 90 triangles as if that hypotenuse is equal to 1. So first of all, what I attempted to create here is an equilateral triangle. So in an equilateral triangle, we know we have 60 degrees, 60 degrees, and 60 degrees. And we also know that all the sides are going to be equal. So what I'm going to do is set each side equal to 1. Now, you notice this isn't one of my special right triangles. In fact, the equilateral triangle isn't a right triangle, but I can turn it into a right triangle by just drawing in an altitude. And the minute I do that, I cut this 60-degree angle into 2 equal pieces. So we can kind of look at this and we could say, hey, that 60 degrees just got cut in half, so this is 30 degrees, this is 30 degrees. Okay, and now we have two 30, 60, 90 triangles. And then the one other thing we know as we look at this whole side, well, this altitude cut this side into 2 equal pieces. And each of those pieces would be half of the total length, so this one is 1/2 and this one is 1/2. So as we think this through, one of the things that'll be really useful for us is we want to think about this angle on the coordinate plane where this is 30 degrees, and I know that this is 1. Well, this distance would be 1/2, and so our goal is kind of to figure out what is this coordinate, and we can use the Pythagorean theorem to find this third side, okay? So I'm going to call that x because it's essentially going to be my x coordinate. And what we know is that x squared plus 1/2 squared has to equal 1 squared. So kind of going through and doing my squares, if I do 1/2 squared, I get 1/4. 1 squared is 1. And then to solve for x, I would subtract that 1/4 and get x squared equals 3/4. Okay, and so then take the square root, and what I would get is I would just essentially take the square root of each piece. I'm going to leave the square root of 3 as the square root of 3, and then I know that the square root of 4 is 2. So the coordinates when this is 30 degrees, I now just figured out that this was square root 3. This distance is square root 3 over 2, which makes my x coordinate square root 3 over 2. And my y coordinate 1/2. All right, and then essentially, so I know this distance is square root 3 over 2. If I had a 60-degree angle, where this is 60 degrees, I can just kind of turn this triangle on its side, where this distance would now be the 1/2, and this distance would now be square root 3 over 2 with my hypotenuse equaling 1, which makes my coordinate pair, now the x coordinate's 1/2 and the y coordinate's square root 3 over 2. So that kind of takes us through on what a 30, 60, 90 triangle could look like in the coordinate plane. All right, so the other one we wanted to look at is a 45, 45, 90 triangle with the hypotenuse being 1. And to solve this one, What we know is both of those lengths, since the 45, 45, 90 triangle has those base angles, that would make both of these lengths equal to each other because it's isosceles. So what I would have using my Pythagorean theorem is that x squared plus x squared has to equal 1 squared. And we just do a little bit of algebra here. I'm going to add together those x squareds and go ahead and square that one. And so then I get x squared is equal to 1 over 2. And then to solve for x, we would take the square root. And we end up with, well, the square root of 1 is 1, the square root of 2 is the square root of 2. And for this situation, we're going to go ahead and multiply that by square root 2 over square root 2 just to get that square root out of the denominator. And I'd be left with square root 2 on top and just a 2 on the bottom. So as we think through this 45, 45, 90 triangle being placed on the coordinate plane, the coordinates for those points would be square root, both the x and the y, would be square root 2 over 2 because that triangle would be an isosceles triangle. All right, the last thing I want to real quick do with you is to review, since you're doing the graded assignment after this video, is how do I turn 30 degrees into radians? So what we're going to do is we always used pi over 180. So 30 degrees would be, you say pi over 180 equals however many radians over 30. And then we have two fractions equal to each other. We can cross multiply. We get 30 pi equals 180x. And then divide by that 180 and get pi over 6. So 30 degrees is equal to pi over 6 radians. And then 60 degrees would just be twice as many, right? Because 30 is equal to 2 times 6. 2 times 30 is equal to 60. So I'd have 2 pi over 6. So 60 degrees is equal to pi over 3 radians. And then lastly, 45 degrees, we would do, let's go ahead and just do pi over 180 equals how many out of 45. And so we get 45 pi equals 180x. Divide that through, and if I simplify 45 over 180, I get 1/4, so pi over 4. So we can say 45 degrees is equal to pi over 4 radians. Okay, so from here, guys, you're going to go a couple pages up in your packet, and I'll even show you. You're going to go past the unit circle. You're going to go past the trigonometric values on the unit circle. And you're going to get to the page that says unit circle graded assignment. I'm going to have you guys just do 1 through 6 for now. And then later on next week, probably on Monday, you'll have some time, since I'm giving you part of the day today, so just kind of keep that in the back of your head. Make sure you're getting these first ones done. I'll be available for questions over the next couple of days. Other than that, be good for the sub. She'll tell me your name if you're bad, so, you know. Have a good one, guys.